So in this video, I'm going to do AMC 10B 2021 fall, problems 19 and 20, which are both pretty challenging problems. I'm not going to lie. They each took me a good amount of time and, you know, not really, you know, they're pretty tough. They're pretty challenging problems. So, and I would love to see if anyone can give me like, how did you do it? What's a different solution, right? I would love to kind of get that type of conversation going. That'd be great. Let n be the positive integer 777 dot 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 777 313 digit number where each digit is a 7. Let f of r be the leading digit of the rth root of n. What is f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6? Okay. Yeah, so looking at this, it's like, oh my God, what the heck do I do here? Right. And these are the kinds of I feel like AMC loves to throw in these weird sort of like more like grindy type of problems, like where you have to do some type of like estimation type of thing, which I'm not a huge fan of as, for math. In math, I like to find like a more logical, interesting solution to a problem and not have to like kind of do like some weird estimation type of stuff. But anyway, if we think about it, if we take this number 777 blah, 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 777, right? We can think of this number as being 7/9 of 9999 dot 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 999, right? Which can also be written as 7/9, and this would be 313 nines, which means we can write it as 7/9 times 10 to the 313 minus 1, right? So that's how we can sort of interpret this number to be. And then what we could do is we can now write this. So let's say, for example, we want to find f of 2, then we're taking the square root of 7/9 times 10 to the 313 minus 1. Now, because 3 to the 13, blah, 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 because 313 is odd, we know we're larger than whatever the actual, like 10 to the 313 lies between 10 to the 312 and 10 to the 314, which would give you two integer values. So therefore, the minusing 1 just brings you a little higher than whatever the integer value of 312 is. So for intents and purposes, we can sort of ignore the -1, right? Because it's not gonna have any effect on the leading digit of the value. Sorry if that doesn't make sense. It's really hard to explain. But now if we think about it, like, okay, so square root of 10 to the 313, well, it's going to be between, again, like 312 and 314, right? So it's going to be the same leading digit as whatever that is, right? So that's going to give you what, 10 to the that'll give you 10 to the what, 166, 156, right? So but what that means is that's just going to throw a bunch of zeros at the end of your number, right? So that's not going to affect the leading digit, right? But notice how we then still have just sort of that 110 left underneath the square root. So we're really left with square root of 70 over 9. 70 over 9 is like set, because 9 times 7 is 63 and 9 times 8 is 72. So it's going to be like 7 point something something, right? Which means it's going to start with a 2 because the square root of 7 is between the square root of 4 and the square root of 9. So it's going to be a 2 leading digit, right? So we know that this has a leading digit of 2. Now, if we do the same thing, but with a 3 in front, right? Now we're going to think about what's f of 3, right? Well, again, 3 goes into 312, right? So that means you're going to divide it, you can divide the 312 by 3, which is going to give you, again, just a bunch of zeros at the end of your number. And you're just still going to have that extra 10 left in there, right? So you're really just looking at the cube root of, again, 70 over 9, which is the cube root of 7 point something, which is less than 2. So that means that's going to start with a 1, right? Now, what if we look at a 4, right? Well, once again, 4 goes into 312. So therefore, you're again just going to have that extra 10 left in there, right? So 4th root of 70 over 9. The 2 to the power 4 is 16, so you're bigger than 1, less than 2, so that's going to be a leading digit of 1. Now 5 is weird because 5 doesn't go into 312, right? But 5 goes into 310. So that means we are actually going to have 3 10s left over, right? So when we think about the 5th root, right, 5th root of 7 ninths 10 to the 313, right, it's going to leave you with actually 1,000, because because it's going to be like 310 is going to divide by 5, and then you're going to have 3 10s left over, power 10 times 10 times 10, right? So we're looking at 7,000 divided by 9, right, which comes out to be it's like 777 divided by 0.777, so like, which you can just do a long division, right? Or you can know like 7 over 9 is 0.7 repeating, and then move the decimal 3 places, right? Now 3 to the 5 is 243. 4 to the 5 is, I think, 1,024, if I'm not wrong. Which is obviously bigger, so therefore this leading digit is 3, and then 6 goes into 312 again. So once again, we'd be looking at 6th root of 70 over 9, 6th root of 7, which is obviously bigger than 1, less than 2. So you have another leading digit of 1. 2 plus 1 plus 1 plus 3 plus 1 is 8. So your answer is A, 8. Oh, I'm not a fan of that problem, but there is a little bit of logical thinking that you can use. That's not too terrible. This one, the next one, it's one of those problems that I thought I kind of was in the right track, but then, whoops, sorry about that. I opened up the wrong thing. I was kind of a little bit off on my solution, and but I eventually did get it using conditional probability, right? Which is the idea that the probability of A given B is equal to the probability of A and B divided by the probability of B, right? So we have, in a particular game, each of 4 players rolls a standard 6-sided die. The winner is the player who rolls the highest number. If there is a tie for the highest roll, those involved in the tie will roll again, and this process will continue until one player wins. Hugo is one of the players in this game. What is the probability that Hugo's first roll was 5, given that he won the game? Right? Right. So we want the probability that he rolled a 5, given that he won, which would be equal to the probability of 5 and 1 divided by probability Hugo won. Now, here's the kind of like weird, easy / tricky part, right? The probability of Hugo winning this game is 1 out of 4. Because if you think about it, if you look at these 4, there's 4 people playing this game, right? And any one of them has the same chance of winning. Nobody has any advantage over another. So like from a symmetric point of view, each one of them has an equal chance to win. So therefore the probability of Hugo winning is 1 out of 4. So this part equals 1 out of 4. Now we need to figure out the probability that he wins, given he wins with a 5, right? Now, so we need to look at different cases that could have happened. One case is that he rolled the 5, but somebody else also rolled the 5. Now keep in mind that Hugo's chance of rolling a 5 is 1 out of 6, right? Now we need one other person to tie with him. Well, we need to choose one of the 3 people to tie with him. And then the other 2 people need to get something that's 4 or less, right? So 4 or less, 4 out of 6 or 2 out of 3, right? They each would need to get something less than a 5, right? Okay, or Hugo rolls a 5. Let's say 2 people tied with him, right? The chance that 2 people tied with him, oh, sorry. And then also there's another 1 out of 6 here, because that we also need the chance that that other person ties with Hugo, which will also happen 1/6 of the time, right? So this is the 1/6 that Hugo rolls the 5. This is the 1 out of 6 that that other person also rolls a 5. any of the other three people could tie with Hugo, and the other two people need to get 4 or less, right? 1/6 chance that Hugo rolls a 5. Choose 2 out of your 3 people. Both of those other people also need to roll a 6, and then the remaining person needs to roll less than a 6, which is less than a 5, which is 4 out of 6 or 2/3, right? Or Hugo rolls a 6. Everybody else also rolls a 6, which will happen 1 out of 6 cubed, right? So it's basically 1 out of 6 to the power 4 because they all need to roll a 6. Roll a 5 is what I mean. So if we can calculate this probability, what would we get? So we're gonna have what? 1 out of 36 times 3 times 2/3 squared, which would become what? 4 over 3 plus 1 over 6 cubed times 3 times 2/3, which is 2. So 2 times, so that's basically 2 over 6 to the power 3, right? Plus 1 over 6 to the power 4. 6 squared. So that's going to be what? 4, we would have to multiply by 6 squared. We need to multiply 2 times 6, so 12. So that's going to be 48 over 6 to the 4 plus 12 over 6 to the 4 plus 1 over 6 to the 4. That's going to be what? 61 over 6 to the 4, right? But remember, that's all over 1 over 4 because that's the chance that Hugo wins, right? So it's going to be 61 times 4, which is what? 244 over 6 to the 4. 36 times 36. Isn't that 260? No, what's 36 times 36? Let me. So that's 1296. Sorry, I saw where my mistake was. What I forgot was that in the situation in which he ties with one other person, he will win half of those cases because those two people will re-roll. So half the time he will win in that situation. So I would need to multiply the first fraction by a half, right? So this would be times 1/2, right? Now in this situation where he ties with 2 other people, he'll win a third of the time because it's 3 people who rolled the same thing. And then in this case, he would win 1/4 of the time. So I actually should get 24 plus 4 plus 1/4. But then remember, we are multiplying this again by 4 because, right, it's 1/4 of the time he wins. So that's what, 96 plus 16 plus 1. That's 6, 112, 113 out of 1296. Sorry, also forgot the case where nobody ties, right? It's possible that nobody tied. And that would happen in the case where each person rolled less than 5. So that would happen with chance 4 over 6 cubed, right? Because each person would have to roll less, each of the other 3 people would have to roll less than a 5. So right, so that would give me what? 4 cubed. 4 cubed is what? 64. 64 times 6. Oh, 64 times 6. 24 and 360. 384. Right, so plus 384. 384. 384 times 4, 6, 1, 8 times 4, 32, 33, 12, 1536. Oh my God. So 1536 plus that over 1. 1296. Kind of see the thought process. So what I was mistaking with this situation was I was forgetting that I was forgetting to multiply by 1/6, which is the chance that Hugo rolls the 5 in the first place. So I don't need to multiply the top by 6. So basically, really all I'm just adding is 64 here, right? Because it would be 4 cubed over 6 to the power 4. So it's 64, because it would basically be this times 1/6, right? So then if I add these together, I get so here I'll just kind of clear everything. So what I end up getting is 92 1/4 over 6 to the power 4, which if you but then this has to get multiplied by 4, because remember, we're dividing by 1/4, right? Dividing by 1/4. So it's going to be 369 over 1296, which reduces to 41 over 144. So again, I'm sorry that I kind of towards the end there was making some mistakes. I have notes, but my notes aren't super easy to follow, and I just kept making like little errors. Like that's why you just have to keep track of everything so carefully, especially when you don't have a calculator. But again, I think leaving the errors is like makes it a little bit more relatable, I think, right? All right, but again, please let me know if you found another way to do that problem. I'd be super interested. All right, I'm going to end there. I'll see you guys in my next video.